Hi everyone and welcome! Today we're going to assemble a MHz display for this front bezel. Yeah, it's the one that I repaired in the last video using ABS slurry. As you may recall, this bezel has a cutout for a MHz display, but it came without one. So in its place there is this piece of plastic which can be removed by removing the two screws. It used to be a nice rectangular shape, but as you may recall from my previous video, I used the plastic from this part to fill in the missing part of the bezel. Since I didn't have an actual display to clone, I had to reverse engineer it by measuring the dimensions of the cutout, the position of the holes, and the position of the 7-segment display. The 7-segment displays of that particular dimension are not very easy to come by, but I was lucky and my local electronics shop had a few of these in stock. The model number is HD1107G, and they are common cathode parts. The digits are 0.39 inches in size, and the display itself measures 12.8 by 9.7 by 7 millimeters. The displays also came with a pinout sheet. How awesome is that? As for the circuit, I reused the design of the TD37S, which is one of the more common ones. Okay, let's solder it. The pins are not taking solder. Let me attach the displays to the board with some white tack and try again from a more comfortable position. It's still not taking solder. Let me try with leaded solder. Yeah, this works a bit better, finally. And at this point, many of you must have pointed out what I did wrong. I was so distracted by the pins not taking solder that I forgot to solder the corners first, adjust the position of the displays, and then solder the rest of the pins. So here's the result. Anyway, this is not too hard to fix. I just need to go over the pins quickly while forcing the display from the other side. After doing this a couple of times, it looks much better. Before going any further, let's install it to the case to check whether my measurements were actually correct. And yeah, it is pretty much spot on. Now let's solder the headers. I like my LED displays on the dimmer side, so I used a 100 ohm quarter watt resistor, but you could use a smaller value. I added jumpers off camera at the always on position for all segments. The display should show 88 regardless of the position of the turbo switch. Unlike other displays, I had to split the headers into two sections, the ones at the top and the ones on the side. This is because of the position of the screws that would not allow me to fit the full headers at the top. But other than that, the functionality is the same as in other displays. And by the way, I have an old video tutorial that explains how these displays can be configured, so feel free to check it out if you have never configured one before. Let's power it on with 5 volts from my bench power supply, and yeah, it works great! Now let's attach it to the bezel. Not sure what this is for, but it might be a good mount for a diffuser. More on this later. Nice, it looks really good. But I think we could improve the way it looks with a diffuser. I'm going to use this somewhat transparent white piece of plastic that I cut out from a milk bottle. A display should push it in place, but I should probably use some sort of glue to keep it on. Perhaps some hot glue should do the trick? Let me know in the comments if you know of a good way to attach the diffuser to the bezel. And yeah, I think this simple diffuser makes it look a bit better. You can no longer see the gap between the displays, and the digits are a little bit less sharp. A black diffuser may look even better, but I could not find any such plastic part in my pile of junk. Anyway, that's all for today. I'm very happy with the way this bezel turned out after the repair and the addition of the display. The PCB for this display is open source and can be found on GitHub, for anyone who may have a similar case and needs to build a display for it. I hope you enjoyed the video, and as always, thanks for watching and goodbye.